Welcome to All This Math. This is Professor Parker, and right about now, I want to talk about how to solve an equation where there are variables on both sides of the equal sign. That's what I want to talk about. All right. Now, I'm gonna do this a couple ways, actually. Right? I'm gonna give it to you like the traditional textbook way, in a way that most teachers will show you how to do it, and then I'm gonna kind of flip it and bounce it a little bit. Then I'm gonna give it to you a way that I actually personally prefer to do, where we do something called transposing. All right. Now, this is the traditional way, right? Where we use the inverse properties and isolate x by itself, and then kind of go on about our business, right? But I'm gonna let you decide which method you like better. Okay. So this is like the traditional method that you'll see in many textbooks and on a lot of the other videos out on the internet. All right, so we have 6x plus 7 is equal to 8x minus 13. And we're trying to solve. We're trying to solve for x, right? We want to know what value of x is going to make this a true statement, right? Because that's really what we're doing, right? We're trying to find out the truth. That's what we do when we solve equations. We try to find out the truth. So we try to find out what number out of all the numbers in the universe, all the infinite numbers, the billions and billions and trillions of numbers in the universe, and really more than that, will make this a true statement. We'll make the left side equal the right side. That's what we're trying to figure out. All right. So we want to isolate x by itself on one side of the equal sign. Typically, since we read the English language from left to right, we want to end up with the x on the left side. So we're going to get rid of this x that's on the right side. But before I do that, well, actually, you know what? I could do that right now. Yeah, let's get rid of this 8x. Let's get rid of this 8x. All right. So how do we get rid of the 8x? And let me back up a little bit. Let me reiterate. Why am I getting rid of the 8x? I'm getting rid of the 8x because I can't solve an equation if I have the variable in two different places. I can't. I need the variable in one place. The variable has to be in one place. And right now it's in two different places. So I got to get rid of one of them. Now, how do I decide which one I get rid of? If you're wondering that, that's an excellent question. The reality is it don't matter which one you get rid of. I tend to like to be able to read my answers as x equals something, right? So if I was to get rid of this x, then I wouldn't be able to read my answer like that because I'm going to have my x on the right side and I'm going to have a number is equal to x. It don't really matter, but you know what I mean? That's just my twist. That's just how I like to get down. I like to have my variable on the left side of the equal sign, right? So that's why I'm getting rid of the 8x. Because when we do math, we should always understand why we're doing what we're doing. And when you sit in class, don't just be all vigorously sitting in class trying to write down everything your teacher is saying or your professor is saying if you don't really understand what he or she is talking about, right? You got to also, like, when you're taking notes, it's not enough to copy the steps of the problem down. You got to write down why you did each step. You got to write down the rationale and the logic behind that. You got to write that down. And if you don't understand, you got to also write the question down because then that lets you know, okay, you know what? I need to holler at the teacher later and ask this question. Or I need to holler at the professor later and ask this question. Like, bro, why did you divide by 2 on both sides? Why did you multiply by 8? What happened to the exponent? Those are the types of questions that you need to have written on your paper, right? It's not enough just to copy the problem down and write every step. You need to write the reasoning behind the step. And if you don't understand the reasoning, you need to write down the questions that you have about each step. All right, so I want to get rid of this 8x. How do I get rid of the 8x? I do the opposite of 8. I figure out what the opposite of 8x is, and I apply that. This is a positive 8x. The opposite of a positive is a negative 8x. So underneath of this, I'm going to write minus 8x. Oh, getting light. All right, let me switch up. Hold up. All right, that's a better drawing. All right, so I got minus 8x right here. But again, with equations, it's all about balance. It's about the truth and it's about balance. Equations are about finding the truth, and we always apply balance when we're going through the process. So if I subtract 8x on the right side of the equation, I also need to subtract 8x on the left side of the equation. Now, I can't subtract from 7 because that's not a like term. That's apples and oranges. X's need to be subtracted from x's. So under the 6x, I write minus 8x. Boom, boom. Now, I got to do my arithmetic. 6x's minus 8x's leaves me with negative 2x's. So I got negative 2x, right? Bring down the plus 7. Boom. Bring down the equal sign. Now, 8x minus 8x, I got rid of that. That becomes 0. That was the purpose. Then I got negative 13, right? So I got negative 2x plus 7 equals negative 13, right? Now I'm getting closer to having x by itself on one side of the equation. Now, I want to get rid of this. I have to get rid of this 7, and I have to get rid of this negative 2. You might be wondering, well, what do I get rid of next? Does it matter? Technically, it doesn't matter, but in most cases, if you get rid of the coefficient first, you're going to create some more complicated math than you actually need. If you get rid of the constant that stands alone first, I think the math will be a lot easier. All right, so I need to get rid of this positive 7. Right now, this 7 is being added. So we need to apply the opposite operation. Whenever we want to get rid of things, when we're solving equations, we do the opposite operation. So what's the opposite of adding 7? Subtracting 7. So we're going to do minus 7 right here. And again, it's about balance. So if I subtract 7 on the left, I'm also going to subtract 7 on the right. So now I got minus 7 over here. Boom. Now, that's gone. This negative 2x comes down. This equal sign comes down. You might be saying, oh, but isn't that 0? It is. You don't need to write that 0. That 0 is not necessary. You don't need to write it. The equal sign comes down. Now, arithmetic, negative 13 minus 7. Negative 13 minus 7 is negative 20. Now, we're getting closer to our end result. We're getting closer to our solution. We're getting closer to isolating x by itself. All I got to get rid of now is this negative 2. Now, the question is, what is negative 2 doing? Negative 2 is being multiplied by x. Negative 2x means negative 2 times x. Keep this in mind. Negative 2x equals negative 2 times x. All right? So the opposite of multiplication is division. Negative 2 over here, boom. Divide by negative 2 over here. Negative 2 divided by negative 2 is 1. That gives you 1x, which is just x. And we have negative 20 divided by negative 2. Remember, dividing a negative by a negative always gives you a positive. Just like multiplying a negative times a negative always gives you a positive. That's going to be positive 10. Right? Now, I think that's the answer. But as I always say, we should check our work. And when you check your own work, that gives you power. Because then you don't have to wait for your teacher to validate you. You already know it's right. Imagine you taking a test, right? And you're solving equations. You go through the whole test, solve all the equations, and you checked all of them. You already know what your grade is. You already know what it is. You don't got to wait. You don't got to be nervous, none of that. You already know what your grade is because you solved every equation and you checked every problem. So you know your answer's right, which is what we're about to do right now. Now, let's check this. Boom. Go back to the original equation. The original equation, right? Wherever I see an x, I replace it with 10. Because if x equals 10, then 10 is the number that makes this a true statement. It ensures that 6x plus 7 is in fact equal to 8x minus 13. So I got to replace every x with a 10. So I do 6 times 10 plus 7 equals 8 times 10 minus 13. Now the question is this a true statement? Let's break it down using order of operations. Multiply this 6 times 10. That's going to give me 60 plus 7. Boom, over here. Multiply this 8 times 10. That's going to be 80 minus 13. Now, what's 60 plus 7? 67. What's 80 minus 13? Also 67. That's a true statement because 67 does equal 67 and 10 was the number that enabled us to get that. X equals 10. So we just proved it by checking our work. We just proved it by checking our work. All right. All right. Now, I told you I was gonna approach this problem and solve it 2 different ways. This is the traditional method that you'll find in most textbooks where you use the inverse properties, right? But it's a method I like to use called transposing, right? I'm a fan of this. I'm a fan, right? I really enjoy transposing. I really do. All right, so watch this, right? Transposing means basically you take terms and move them to the other side of the equal sign. Terms that are on the right side of the equal sign, you move them to the left. Terms that are on the left side of the equal sign, you move them to the right. That's all transposing is. You're just moving something from one side of the equal sign to the other. In the context of algebra, that's what transpose means. All right. So basically, what I'm going to do is I want all my x's on the left side, and I want all my constants, like 7 and negative 13, on the right side. So really, I just pick them up and move them. So watch this. This 8x, I'm moving it over here. This 7, I'm moving it over here. Now, one caveat, meaning one thing to be cautious about, one thing to look out for. When you move the terms to the other side of the equal sign or transpose them, you have to change the sign. You have to change the sign. Switch the side, change the sign. Switch the side, change the sign. All right? Young brother named Hanif from back in the day. I taught him like 16 years ago, started my career. He put me onto that. He was from South Philly, from 19th Street. Shout out to Neef, right? So 6x is here. The 8x moves over. It was a positive on the right side. But when I move him over, now it's a negative 8x. Bring the equal sign down. What about this 7? Move that 7 over there. Now, does it matter if I put the 7 in front of the negative 13 or behind the negative 13? No, it doesn't matter. As long as it's on the other side of the equal sign. So now this positive 7 becomes a negative 7, and then you got the minus 13. Now, if you wanted to, you could write negative 13 minus 7. You could do that too. It doesn't make a difference. Now, the beauty of transposing is now that you have all the like terms on one side and all the like terms on this side, you can just combine like terms. And you get to the answer much faster, right? So 6x minus 8x is negative 2x. And negative 7 minus 13 is negative 20. Now, if you were taking notes and you wrote down the method that we used to do this problem the first time around, you'll notice that we end up with the same setup. At one point, we had negative 2x minus 20. We still do. A lot of times, like when you transpose, you still end up with the same answer. And a lot of times you end up with the same simplified equation, right? So now I'm still trying to get rid of negative 2, just like I did in the last method. All right. So I got to do the opposite of negative 2 times x. So the opposite of multiplication is division, right? So I'm going to do this. I'm going to divide by negative 2 on the left, and I'll also divide by negative 2 on the right. So now I got x equals positive 10. I keep putting that plus on there. You don't need that. You don't need that. But I just keep saying the word positive out loud, so I just keep writing it, you know. But anyway, this positive sign is not necessary. I'm just being extra. That's all. But, you know, just know that this is positive 10. All right. And so we got the same answer. I don't need to check it again because we already checked it the last time we did the problem. All right. So this is how we solve equations. I just showed you two different ways to solve equations when you have variables on both sides of the equal sign. All right. So when you're in class, you see questions like that. You know how to attack them, knock them out, break them down, and also check your work. Make sure you check your work. Okay. All right. So if you haven't subscribed to the page already, subscribe. If you haven't shared a video like this with somebody, share it. All right. Like the video. All right. Even if you didn't like it, still like it. You might as well because you sat here all this time and watched it. And also, as always, remember, there's all this math all around you. Peace.